partial variations. Examples. X is partly constant and partly varies as y. When y equals to 2, x equals to 30. And when y equals to 6, x equals to 50. A. Find the relationship between x and y. B. Find x when y equals to 3. Solution. Solution. Now, let's look at the first statement. S is partly constant and partly varies as y. X is partly constant, meaning x equals to, for partly constant, it means we look for a value, or let me say we look for a constant k for this. Constant k, partly constant. So we use k for this, and partly varies as what? As y. Partly varies as y, meaning we have something like what? We look for another constant for this. Partly varies as y. Same x is going to be plus another constant, c, y. It means that we have two constants now. For the partly constant is k. For the other constant of variation is c that we have here. So we have two constants, k and c. So I will write here where k and c are constants. Where k and c are constants. Now, we have done the interpretation of the first part of the problem. So what we need to do now, when y equals to 2, x is 30, and when y equals to 6, x is 50. Now we use the first one. When y equals to 2, s equals to 30. When y equals to 2, s equals to 30. So 30 is equals to k plus what? C into y. What is y here? 2. So in that case, what do we have? It means that 30 is equals to k plus what? What is c times 2? That is 2c. So this will form our first equation, equation 1. Now, for the second part of this, the second part of the second statement, when y equals to 6, x is 50. So we go back to this again. When y equals to 6, x is 50. So s is at the left hand side. We have 50 is equals to k plus, then we have c into y. What is y here? 6. Can you see that? So it means that 50 is equals to k plus 6c. c times 6 is 6c. So we have equation 2. Now, we now have two equations. And this equation, they are going to be solved simultaneously. And the preferable method of solving this kind of equation, of solving this kind of simultaneous equation, let me be specific, is the elimination method. Because we have k here and we also have k. So we can subtract one equation from the other. Let's do that now. Using elimination method. Using elimination method. Using elimination method. So subtract equation 1 from equation 2. From equation 2. We subtract equation 1 from equation 2. So what do we have? Subtracting equation 1 from 2. Now let's look at from the left. Look at 1. This is equation 1 and this is equation 2. Now, from the left, we now have 50. We are subtracting this from this. This one from this. So it's very important. Take note. 50 minus, what do we have there? 50 minus 30. That's at the left-hand side. And also we have k here. You can see. K minus k. Then what do we have? Then plus equation 2, we have 6c minus what? 2c. So what do we have? 50 minus 20, minus 30 rather. What do we have? We have 20. K minus k, that is 0. So that one has gone. 6c minus 2c. What do we have? 4c. So from here, we can now have we have 4c is equals to 20. So what do we do from here? We are going to divide both sides by 4 in order to get the value of c. 4c divided by 4 is equals to 20 divided by 4. So 4 here 1, 4 here 1. C equals to what? 20 divided by 4, what do we have? 5. Now we know the value of c to be 5, but we also need to get the value of k. So how do we get the value of k? Now we can use any of the two equations, either equation 1 or equation 2, to get the value of k. And how do we do that? We are going to substitute the value of c in any of equation 1 or equation 2. Now let me use equation 1. From equation 1, I have 30 is equals to k plus 2c. Now, 30 is equals to what? K plus 2c. What is c now? C is 5. Now, I have 30 equals to k plus what? 2 times 5, that is what? 10. So, collecting like 10, when this plus 10 moves to the other side, it becomes minus. So, we have 30 minus 10 is equals to what? K. So, what is k? K equals to 20. Now, we have the values for the two constants, k and c. So, the next thing for us to do is to write the final answer for the relationship between x and y. Don't forget, this is the solution for the A part of the question. So, we now say recall that x equals to k plus cy. That is from here. So now, s will be equals to what? What is k? K is 20. So we write 20 here. What is c? C is 5. So the equation connecting or the relation between x and y is x equals to 20 plus 5y. That is the solution for the first part of the problem. Now, let's go to B. For the B, find x when y equals to 3. What do? What are we going to do? Now, x equals to what? 20 plus 5y. We have to find x when y equals to 3. When y equals to 3, it means that anywhere we see y here, we substitute 3 as y. So we have 20 plus 5 into 3. Anywhere we see y, we put 3. So in that case, x equals to what? 20 plus what? 5 times 3. That is 15. Then x equals to 35. 35. That is 20 plus 15 is 35. So it means that when y equals to 3, the value of x is 35. That is the solution to the problem. Thank you.